the heartland of America, the gateway to the West. This is Engineering Tomorrow, the podcast, keeping you entertained and in the know on the latest commercial and industrial heating, cooling, and water treatment technologies.
All right, welcome to another episode of Engineering Tomorrow. I am your host, Brian Gomsky, and we have a very exciting guest today, Rob French with Flowtech. Rob, thank you for being here today. I know you traveled a long way.
You bet, no problem. Just flew in from Salt Lake City.
And how does it feel knowing that within 1 mile, we are literally sitting below a river right now that is only a few feet from the top of a levee?
Well,
so if we abruptly have to leave, it's because we're sinking. So with that said, let's just start. Today we're going to talk about something very important to the earth, to us, to life, which is water, right? We're mostly made of water. We need to drink water or we're going to die. Water is important in a lot of heating and cooling processes. And Rob, in my opinion, I would say you are one of the experts within the United States when it comes to water and managing water quality.
Appreciate that.
Rob, tell me a little bit about your background and how you even got involved with water.
You know, I never intended to start in water. It was one of those situations where I was graduating with my MBA and I was looking at my future and what I wanted to do. And I was basically hired by a company to help run their organization. And in the process of doing that, they ended up selling that company. And the owner of that company actually owned about a dozen different companies. And my MBA thesis was on another company that he did. It was for water disinfection. Mm-hmm. And my MBA thesis was basically telling him that he shouldn't have hired me because the product that they were developing was still several years away from being something they could sell in the U.S. market. And so when I gave him that news, here's my thesis and great technology, but it's not ready for a long time. Basically, he looked at his other companies and said, man, we could sure use your help in a few other areas. And I got into filtration and then into treatment. So it was an interesting progression. It took me a path that I never expected in the first place.
All right, so here you are. You've kind of jumped in head first, no pun intended, to water. What does it take to really learn the ins and outs of water treatment and basically keeping water clean?
Really, it comes down to being interested in it. So when I first started getting into filtration in the first place, it wasn't that exciting to me. And after about a year, I realized, you know, this is what I'm doing. This is where I'm going. And water is a natural resource that's critical to the future of our planet. And at that point, I realized, you know what, this is the future of our world, is the direction our water goes is the direction of our planet and our health and our lives. And so really it's being interested. Anything that you're interested in becomes something that you end up learning a lot about. Yeah.
Flotech, you treat potable and processed water. I want to focus first on potable water, which is drinking water potentially. What are the problems with getting water from the treatment plant to your house or your building? And then once it's in the house or building, what are the problems there? So let's start with that.
Oh, do you want to talk about our dirty little secrets that no one wants to talk about?
Absolutely.
Oh, man. Okay. So I'll start with the dirty secrets.
Okay.
And we'll go into other things after that. But the stuff that no one wants to talk about, the secret that is really kind of scary, is all of our pipes have been there for a very long time. Mm-hmm. And for the most part, they're covered in slime called biofilm. And that's a protective housing that's emitted by bacteria. And so
biofilms, like when you have a kiddie pool and you leave it out for a couple days and you feel the inside and it's greasy and slick, that's biofilm, right?
Yes.
Okay.
Yeah. Or your dog dish and the next day it's got a slime layer. Yeah. Or if you want to be really grossed out, you wake up in the morning and your teeth feel slimy. Mm-hmm. That's biofilm.
Okay.
So if you want to talk about biofilm, you can talk to your dentist about it.
Okay.
So our pipes have biofilm lining them.
Those are the pipes that are coming from even the ones coming from the water treatment plant to your destination are filled.
Oh, yeah.
Okay.
So, and then when it gets scary is there have been some studies about Legionella outbreaks that have occurred. Well, if you trace them back, some of them have been directly traceable to some construction upstream.
Okay.
So in other words, they did some road construction, they disturbed the pipes in some way, maybe it was some vibration or actually moving pipes, but in some way those pipes got disturbed, and in that process, some of that biofilm got dislodged, went downstream, and caused an outbreak of Legionella. Now, Legionella is not the only waterborne bacteria that's a concern to humans, but it's definitely one of the most well-known lately with some significant outbreaks.
Sure. I was reading a story a couple of months ago about someone who used tap water in a neti pot.
Yes.
Just from, you probably heard of this, down south, and they got bacteria, went in through their nose, in their brain, they ended up dying.
Yes.
So it was a fluke, but I mean, that is scary to think about. And that's the water you trust from the government or the municipality sending you clean water.
Yes. So there's actually a limit for the amount of bacteria that we will accept. Okay. So 5,000 or 500 colony forming units per milliliter is the typical threshold. Above that, it's typically not acceptable in the U.S. to be used as drinking water. Below that threshold, it's considered safe. And it could be any kind of bacteria in there. And there are certain bacteria where you really shouldn't have any, fecal coliforms and other bacteria like that are much more of a red flag. But there will always be a percentage of the total bacteria counts that are Legionella or other bacteria that are still harmful to humans.
So, all right, so we've got this water coming from the city or wherever it gets to your building. What are the problems? Is it the same problems, or are the problems even exponentially greater once it gets into your building?
Oh, that's a good question. And it depends on how old your building is and the piping system in your building. So, for example, if you've got a really old building and you've had periods of time where the water's been stagnant for any period of time, there's a great chance that not only are you going to have rust in your system and stuff like that, but you'll have that biofilm. Once the biofilm grows, it's extremely difficult to remove with traditional chemicals.
Okay.
So if you put enough chemicals in to remove that biofilm and disperse it and everything, there's a very good chance you've actually eaten a lot of your metal away.
Okay.
Possibly eaten some of your seals on your pumps or other equipment. So it's very difficult to penetrate that biofilm.
And is this... If we're talking about treating with chemicals, what type of chemicals are? Is this toxic, or what is this that we're putting in the water to get rid of this biofilm?
Oh, sure. Absolutely toxic.
Okay.
Yeah.
So what are people doing, if anything, right now to prevent bacteria from coming out of their faucets in commercial buildings? Let's start with, because I would assume in residential, probably not many people are doing anything, but let's talk about commercial.
Sure. So in commercial... for the most part, they just trust the chlorine in the water.
Okay.
And no one really thinks about it too much. When you go into a healthcare facility, they do care.
Okay.
Because there are certain mandates that they have to follow. So commercial buildings, residential buildings, not so much. It's kind of forgotten and ignored.
Okay.
Maybe you live in a place or have lived in a place where you always thought, man, this water just doesn't taste as good, or it smells a little bit or something. And you know it's your building because the building next door doesn't have that problem.
Okay.
So that's in your pipes, right? Now, if you go to a healthcare facility, they're actively monitoring it.
Okay.
And if they're not, they should be, and they know they should be.
Okay.
So they've tried several different technologies to different levels of success.
We'll get to Flowtech in that aspect, but before Flowtech was even around, what were some of the different things that they were trying to mitigate this?
One of the more successful things they've done is superheating the water.
Okay.
And it's not truly superheating, but bringing the water up above 140 degrees.
So the water comes into the building and goes into a tank or something, or how are they heating that?
They'll usually use boilers.
Okay.
So they heat up the water, and this is not something they do on an ongoing basis. This is a very temporary thing. So, for example, if you go into a hospital and they observe high levels of Legionella in that hospital, so then they might, for, say, an hour or half an hour or a couple hours, depending on how hot they treat that water or they heat that water, they'll recirculate that water or at least do a single pass with that water where it may be 150, 160 degrees to try to kill off as much bacteria as they can. The problem with that is that first layer of biofilm becomes sacrificial, but the lower layers still remain intact.
Okay. What do you mean by that?
What I mean is your immediate bacteria counts drop substantially after a heat treatment like that.
Okay.
However, after days or weeks, the bacteria counts climb up to similar rates to where they were shortly before you did the hot treatment.
How can Flowtech, in this instance, help mitigate that problem?
The Flotec does a very interesting thing with bacteria. That pulse signal is very disruptive to the cell membrane. And in addition to damaging the cell membrane on the individual bacterium, it actually has a dramatic effect on biofilm at the whole system level. So as the signal propagates throughout the entire system, you'll start to see very rapidly within a day or even just a couple days, biofilm sloughing off. And so in a system that has substantial amounts of biofilm clinging to the pipes, that biofilm will start biodegrading very rapidly. And you'll start to see, at first you might see a slight increase or even a spike in bacteria counts, but then very rapidly as that biofilm sloughs off and biodegrades, and it's more than 99% water. So when people kind of freak out and say, oh, gross, that slime is biodegrading, well, it's mostly biodegrading into water and, some dust and other stuff.
When you use the phrase slough off, is it dead at that point, or is it just releasing itself from that pipe? Or is it both? Okay,
so the biofilm, the slime itself, is not living, but the bacteria is.
Okay.
And the bacteria start jumping ship, so to say, very quickly. So they feel the signal and it hurts them. And so they think, oh man, I'm no longer safe inside this biofilm that historically has protected me. And so they start jumping ship thinking, hey, we're going to be safe elsewhere. And then they get killed even more quickly as they start floating through the bulk water.
Where is the United States in terms of regulation for this compared to other countries?
Oh, that's an interesting question. So around the world, the United States is in a pretty good place as far as regulation for water. Now, there are some places in Europe that are actually about a decade ahead of us.
Oh, wow. Okay.
Right. So when you're talking about domestic, and especially when you're talking about cooling towers, they're about a decade ahead of us. So we trend about 10 years after them. So the kinds of things that they're doing now is what we're going to be doing in about 10 years. And we tend to not take it maybe quite as far as they do, even after we catch up to them.
Okay.
So, for example, if they do any work on cooling towers, they've got to be in full protective gear so that they don't breathe the air in the cooling tower. It has to be totally shut off. Whereas here in the States, we've adopted a lot of the same legislature, or we're in the process of doing so, but we don't take it quite as far as they do oftentimes.
If you're a hospital today and currently you are using superheat or nothing at all, what would be the best thing to do to ensure your water is going to be as clean as you possibly could get it? Okay,
now, obviously I'm representing Flowtech.
Sure.
So the first thing I'm going to think of is making sure your Legionella counts and your total bacteria counts are very low. And if the amount of chlorine in the water is doing a great job for you, wonderful, you're there. Okay. But if it's not, then the least expensive and most effective solution that I know of is putting a Flotec system on that water system to destroy that biofilm, reduce the total bacteria counts, and also, as a corollary, prevent scale on your equipment.
Tell me specifically about Flotec and what Flotec does.
Okay, Flotec is a very unique product. The concept is that we take an electrical signal and we conduct it into the water through some kind of metal surface, whether it's a pump or a pipe or a metal flange. But once that signal is conducted into the water, it then propagates upstream and downstream. And that signal propagation is really unique to this product. And that pulsed, we have a pulse decaying sine wave that we cut in and out up to 40,000 times per second. And the net result of that pulse signal is several-fold. The first is that it strips off the surface charge of different particles in the water. And there's a much stronger tendency towards a negative charge. And no one really knows why. Scientists have a lot of explanations as far as how to describe it, but no one's really been able to explain why. It's kind of like gravity or electricity.
Sure.
We can describe it, but we don't know why.
It's there. It happens.
Right.
Right.
So with that primarily negative surface charge on most particles in the water, they repel each other. And so it's a very interesting effect when you've got ions dissolved in the water that at some point want to come out and form scale, but they're repulsed by different suspended particles in the water. And so they can't bond onto those, and they end up bonding onto your heat transfer equipment, your shower head, your sink, those kinds of surfaces. Well, if you can strip off that surface charge and those ions are no longer repelled from those suspended particles, now they naturally want to bond to them. They're so plentiful in the water that that's the first place that those ions are going to touch anyway. And so if you can just remove that surface charge, which Flowtech does, then it's very natural and very easy for those suspended solids to become a gathering place or a nucleation site for different salts and different minerals to precipitate onto.
Mm-hmm. Tell me more about the device and the equipment itself. What does the process of getting it installed look like? How long does it take? And what could they expect?
Okay. It's a very simple and non-invasive procedure to install a Flowtech unit.
Okay.
Basically, you're taking a low-voltage cable and you're conducting that low-voltage signal into the water. We typically have what we call a signal tag, which is really just two wires that are, for redundancy, it's the same signal. And then we tie them together inside of a little box that has flanges on it, and we just clamp it onto the pipe is the most common form of installation. Mm-hmm. We will sand off the paint to make sure we have metal-to-metal contact, and once it's installed, you can spray paint over it or put insulation over it. That's fine. But because it's really just a more industrial way of attaching a wire to a pipe, you could also just cut that box off of our two wires and twist those two wires together, crimp an eye onto the end of that, and put a bolt through the pump casing or through a pump or a pipe flange. So it's really just we're conducting an electrical signal into the water. And so whatever makes the most sense for your application, and usually it's just simply strapping it onto a pipe. And so we need 110, 120 volts, and we ask for a 4-amp circuit. Really, it only consumes about 15 watts.
Okay. So we're sending an army of electricity, low voltage, through the entire water system. We're killing bacteria, getting rid of biofilm. Does the signal weaken as it gets farther away from the main unit?
Sure, absolutely.
Okay. And how do you determine we need to add another unit or we're fine? What does that look like?
Okay. We do a couple different things. The biggest factor for us is the pipe diameter.
Okay.
So to force the signal to propagate, we need to make sure we're putting enough signal or power into that water to make sure it's bouncing off the inside of the pipes back and forth, up and downstream. And as long as we do that, for the most part, that takes care of it. Now, if you're in a skyscraper and you're trying to treat 60 levels or floors, and you've got 100 branches on each floor because you've got a lot of different rooms, faucets and toilets, and et cetera, and you want to protect those all from scale or from Legionella, then every time we have a split, we're going to degrade some of our signal. It's going to get split between the different piping systems.
Okay. So
in a system like that, we would absolutely put some booster units in to make sure we've got sufficient signal on each of the floors. On a single pass system that's very simple, one unit is plenty. On a closed loop, a single unit is plenty. On an open recirculating loop, one unit is almost always plenty. Okay,
so I'm either a building manager, I'm a building owner, I'm listening to this podcast. Are you offering any type of guarantee that this is going to work, or how does that work? We get it on there. What's the follow-up after that?
Yeah, that's a great question. And because this is an alternative technology, it's an emerging technology, there are a lot of people out there that aren't aware of it or are not convinced that it's going to work for their particular application. So we absolutely do put guarantees in place to the point where we will even do trials.
Okay.
We will give away the hardware for a certain period of time, predetermined.
Sure.
We have a trial form that we ask the customer to fill out to make sure we're all on the same page, to make sure we agree on the pass-fail criteria and the length of the trial.
Okay.
And then we proceed with the trial, and we document everything week by week, month by month, showing the customer that we're doing exactly what we said it would do. And if we can't, we'll take the hardware back and never charge the customer anything.
What goals are you setting, or like what are you looking for? Or maybe can you explain some previous installation success you've had and what you're using to determine that this is a success?
Sure. We did an installation in Death Valley, California, the hottest place on earth.
Yep.
And the application was extremely difficult. The water had over 300,000 parts per million total dissolved solids.
Okay.
So it was a sludge.
Okay.
In fact, that's where we get borax. So it was a borax plant.
Okay.
And they pump this solution from an underground lake. It's a brine solution. Then they force it through some heat exchangers that start to scale up within minutes of operation. And they used to have to shut down about 480 hours per month to descale those heat exchangers.
Oh, wow.
We put some Flotec units upstream from those heat exchangers, and those units never scaled up again.
Oh, wow.
Yeah, to the point where they even decommissioned one of the heat exchangers because it was no longer needed.
Okay. What levels are you looking for? What bacteria counts are you looking for to consider it a success? And where do you measure that from?
Okay, so if we're looking at a domestic line and we're measuring Legionella, we typically want to be under 10 colony forming units per milliliter because that's considered non-detect level.
Okay.
If it's a cooling tower, we want to be under 10,000 colony forming units per milliliter, and that's total bacteria counts. That's the CTI and ASHRAE guideline. For us, we typically want to be well under 1,000. Again, drinking water is around 500.
Okay.
And I would say probably more than 70% of our installations, our bacteria counts are in drinking water range.
Okay, great. We spent a lot of time talking about potable water. I'd like to shift to another industry you serve, which is on the process side. Tell me a little bit more about that.
Okay. Can you give me a specific process application?
Let's talk about cooling towers.
Okay. So that's an application where you have a heat transfer surface, a chiller or a heat exchanger, some place where you're applying heat to the water. Then you take that water to the cooling tower and do some evaporation to reduce the water temperature. And so that's the loop. And as you're evaporating water, what you're leaving behind is minerals. And so those minerals get more and more concentrated until the water is too dirty to continue to use.
Okay. And what does that look like physically?
Well, for the most part, the water still looks like drinking water. It might start to get a little bit cloudy.
Okay.
With traditional chemicals, it often is cloudy, might have a smell to it. A Flotec treated system, the water should be crystal clear and there should be no odor to it at all.
If I'm a building manager and I'm managing the tower, and I think quite often a lot of people, either maybe smaller operations have no water treatment, or I've seen some people even just throw chlorine tabs in the basin. What are the problems I'm dealing with at that point before we even get into what Flotec can solve there?
Sure. So let's say you throw in some of those chlorine tabs, and after 6 months or a year, you notice some shiny circles on the bottom of your basin floor. Mm-hmm. That's because you're losing metal. Okay, so you're actually eating holes slowly into your basin. And as long as that chlorine circulates sufficiently, you might be able to get the bacteria counts low enough. However, if that chlorine does not circulate sufficiently, you may not be controlling the bacteria counts throughout the entire system.
Rob, how long has Flowtech been around?
So the division that I run has been around for about 5 years. Okay. The Flotec Systems company has been around about 8 years.
Okay.
And the underlying technology that we base this product off of has been around for over 20 years in Europe.
Okay. Tell me about some of the more unusual installations you've done over the years.
We did a power plant in Cuba that actually takes ocean water in as their makeup for their cooling tower. Okay. And the difficulty there is obviously ocean water has a lot of biological growth in it. Yep. As well as highly saline content. So the corrosive nature of that water is very difficult to deal with. What they found after they installed Flotec is they were able to get rid of their biocides entirely, get rid of their scale inhibitors entirely, and they had 2 corrosion inhibitors. They got rid of one of them, and the second one they put down to 50%.
Oh, wow.
But they are always going to keep that second corrosion inhibitor in place because this, again, is salt water from the ocean.
Sure. Do you have any idea how much money they saved after installing Flotec versus their previous setup?
Well, we have an idea from the chemicals.
Okay.
And in the first couple months, it was hundreds of thousands of dollars.
Oh my gosh! Wow.
But the first time they didn't have to shut down the power plant due to cooling tower issues, I have no idea.
Okay.
I mean, I have no idea how much money that saved.
How about, do you have any other unusual installations?
Oh, we've got a wide range. We've done some extremely large heat exchangers. We've done basically, if you've got biological issues like bacteria counts or biofilm or scale issues in water, we typically have a pretty good solution for that. Sometimes we did a really unusual one. We're in the process of it right now. We're on a data center, and their humidifiers were scaling up, and we were able to solve that problem. But then right next to the data center is a lake.
Okay.
And so now we're in the process of cleaning up their lake by putting Flotec on some recirculation pumps. It's a very unusual application. It's not one that I would typically do, but yeah, that's a strange one.
So you could technically do fountains and water features for like hospitality?
Yes. Yeah. So for example, at UCLA, we're on their fountains. In fact, that's a very common application for us, is to prevent scale on the nozzles and also reduce the bacteria. A lot of people think, oh, cooling towers is where Legionella comes from, but a lot of water features have actually, even though the water is cold, a lot of water features have been sources of Legionella outbreaks.
Oh yeah, I mean, especially you go to these fancy hotels and they've got water spraying out and the mist is hitting your face, and like there could definitely be Legionella in there if it's not properly treated. Yeah. Which who knows who's really treating it or not. Tell me about where regulation is for that right now.
As far as
if there is any
open air misters and things like that?
Pools, spas, water features, stuff like that. Is there is it by law, do they have to treat that or no?
Okay, by law, pools do have to be treated.
Okay.
There's a certain amount of free chlorine that's required. And what's really interesting is Flotec actually breaks apart the chloramine molecule. So if you get chlorine bound with sweat and urine and dirt and other things like that, it forms a chloramine, which is basically bound chlorine. It can't do its job.
Okay.
But when you break apart that molecule and you free up the chlorine to do its disinfection, then it's much more effective. So there's a limit as far as how much free chlorine is required in a public pool. Not in a private pool, but in public pools. So if you were to install Flotec on a pool, for example, you would see an increase in free chlorine even though you're not dosing it any higher. So as long as you dose the pool by free chlorine, you'll notice a substantial reduction in chlorine use.
Going back to regulation again, what about regulation on the healthcare side?
On the healthcare side, there is. And there was a memorandum sent out in 2017 to all Medicare and Medicaid recipients, so healthcare facilities such as hospitals, assisted living centers, those kinds of facilities. And they have to measure the Legionella in their drinking water.
Okay.
So again, we're talking about potable. And not only do they have to measure it, but they also have to make sure that the Legionella counts are low. So they have to take proactive measures to reduce the Legionella counts. And if they're found that there was some kind of infection and they weren't doing a substantial effort to reduce the Legionella, then they are liable. And not only can they be sued by individual parties, such as the family members of someone who got sick or died, but the government can actually fine them as well.
Flotec sounds really great. Have there been any independent testing done on Flotec to back up the claims?
We actually have had quite a few independent tests.
Okay.
Some done by potential customers that were interested in our technology, and also by independent bodies. So the Special Pathogens Lab and the University of Pittsburgh have done numerous tests following an ASHRAE protocol. And we were not the first system that they ever tested. We are the only chemical-free system to date that has achieved a statistically significant reduction in biofilm. So we achieved a 3-log reduction, or a 98% reduction.
So Flotec has a lot of solutions. What industries have we not talked about yet?
Well, we've talked about commercial, and we haven't really talked about residential. That's actually a separate division that handles residential.
Okay.
We do light industrial, we do heavy industrial, we do power, We do municipal. So we're talking about disinfection at wastewater treatment plants, things like that, where it could be either related to bacteria reduction or scale prevention. And then there's an entire different industries inside of those. So, for example, we do a lot of pulp and paper mills.
Okay, say that 5 times.
Yeah, no kidding. We also do a lot of food processing.
Okay.
So, and again, a lot of it is very specific to the industry, whether it's biofilm prevention and removal, or if it's bacteria reduction, or if it's scale prevention. But basically, if you've got water and you have scale or bacteria problems, we probably have a really good solution for you.
What was the worst water you've ever seen? And when you saw it, were you thinking, how are we going to treat this? And how did that go?
Well,
you don't have to name the location or anything. Just tell me something good.
Okay. Well, I'll say it was Phoenix, Arizona.
Okay.
Okay. And it wasn't that their water was the worst I'd ever seen. Mm-hmm. It was up there. But the problem was the source changed very frequently. So in one summer, we counted 4 different sources, all within about a month and a half. And as far as water treatment goes, you can handle bad water. What you can't handle as easily is water that changes qualities substantially in a very short period of time.
Okay.
And that's what was happening at this site.
What do you mean by different sources?
So they could be pulling from different aquifers. They could be pulling from a different wells.
Okay.
They could be pulling from reservoirs or lakes. And so if they're coming from different water sources or different treatment facilities, then some of that water could be very soft. Some of it could be very hard. Some of it might have high sulfur, and you can smell that when you shower. Some of it might have iron, and so you notice some iron staining. So it really depends on your source. And sulfur and iron are really more related to wells than they are to traditional potable water.
Okay. And was Flotec able to help them?
No.
Wow.
No. In fact, Flotec may actually make the iron more noticeable, or the sulfur. You might be able to smell it more because we cause some of the minerals that would cause the scale to precipitate out that kind of mask some of those problems.
Sure.
So
that's probably not your typical water that you see, right?
No, that's pretty uncommon. Now, if we have well water with high iron or sulfur, sulfates and such, that's really not a problem for commercial or industrial uses. That's more on the domestic side. So inside your house, when you're showering, you smell the sulfur a little more, or you might notice some more iron staining. But as far as in commercial or industrial applications, those really don't impede us. Okay.
Rob, how do people reach out to Flotec, and how do you go to market in different states?
So primarily, we go through reps.
Okay.
So we have different channels that we go through. So we have commercial light industrial reps. We have heavy industrial power reps. We have other reps as well, but those are our primary segments. So if you're in a commercial building or a hospital or something like that, you typically acquire our products through a commercial light industrial rep.
What can you expect? Let's say I'm a building owner. I've got a problem. What can you expect when I reach out to one of your reps, and how does that process go?
Okay, so they come on site, they look at your facility, and they identify the problem, and they say, oh, this is bacteria related, or this is a scale problem. And you say, well, how do I fix it? And they say, you know what, we've got this really cool technology, and if you trust them, then you give them a purchase order, and your problem is solved. We have service technicians that are certified by us to take care of our equipment and make sure your system is operating properly. And if you believe this is too good to be true, but you would still like to test it out anyway, that's when we would do the trial.
Okay.
And we would go through and document exactly what would be the pass-fail criteria and absolutely prove to you that it does what we say it does.
And do you have case studies that we can find on your website?
We do. We have quite a few installation pictures as well. We actually keep our website pretty sparse because we try to channel everything through our reps.
Okay.
However, our reps do have quite a few case studies that they can send out.
Okay. Let's say I pulled the trigger. I've got it installed. What does the maintenance look like moving forward?
Okay, so our equipment itself doesn't really require any maintenance.
Okay.
So if you put this on a domestic or a potable water system, maybe once a year, check the signal.
Okay.
That's really about it. But a cooling tower is different.
Okay.
Anytime you have evaporation, you've got to maintain that system.
Okay.
And so that means frequently, at least once a month, going out. So a power plant, they'll check every 8 hours. Every shift, they're checking the water.
Okay.
If it's a high school, they're lucky to have someone check it once a month, even though they should
Sure.
be checking it at least once a month.
Okay.
So if you look at the manuals for all the cooling tower manufacturers, they're always going to recommend at least monthly service on their equipment, and we recommend the same.
Is that the tower manual? Is that what everyone throws away as soon as it's installed?
Right. So the contractor, when they go to install it, they disregard it very quickly.
Of course. Yeah.
Now, that's not all contractors. We love contractors. We're not trying to point our fingers,
No.
but that's typically what happens.
All right. Rob, thanks again. We didn't drown. The river has not gone over the levee, and I know you have to catch a flight. Hopefully we can have you back again soon. Thank you again, and listeners, keep engineering for tomorrow today.
You've been listening to Engineering Tomorrow, the podcast. For more insights and downloadable content, please visit our website at www.engineeringtomorrow.blog. Until next time, engineer for tomorrow, today.